What if I told you that a single line of Python code could generate a publication-ready chart that would take hours in Excel? That's exactly what Seaborn lets you do. And by the end of this video, you will be building stunning, insightful visualizations like a pro. Today, we are diving deep into one of the most powerful and elegant Python libraries for data visualization, that is Seaborn. In today's data-driven world, the ability to not just analyze the data, but to tell a story with it is one of the most valuable skills. And Seaborn makes that incredibly accessible. Whether you're a data analyst, an aspiring data scientist, or a developer who works with data, this course is going to level up your visualization game significantly. This tutorial walks you through Seaborn's core syntax and how it thinks, the essential plot types, covering distributions, relationships, and categorical data. You then learn how to make your charts visually polished using themes, color palettes, and styling options. From there, we will explore multivariate visualizations like pairplots, heatmaps for deeper analysis. 3 real-world projects on the Titanic and restaurant tips datasets give you hands-on practice, after which you explore how Seaborn integrates seamlessly with Pandas and Matplotlib library. This course wraps up with best practices for exploring publication-ready charts, a guide to common errors and how to fix them, and a final capstone project building a complete Iris dataset dashboard. Also, a quick info. If you're interested in learning Python and Seaborn and want to start your journey into data analytics, then this Simplilearn Data Analyst program is for you. In this program, you'll learn how to analyze the data, work with databases, and create powerful visualizations using industry tools like Excel, SQL, Python, R, Tableau, and Power BI. This program includes live interactive classes with industry experts, hands-on projects, and a capstone project where you apply your skills to real-world business problems. After completing the program, you will earn a Data Analyst Master Certificate from Simplilearn, along with Microsoft Course Completion Certificates, which will add a strong value to your professional profile. You'll also get access to Simplilearn's Job Assistant program, which supports you with your resume building, profile highlighting, and connections with hiring companies to help you move closer to your dream data analyst role. Before we dive deep into the topic, let me ask you a quick question. Which parameter in Seaborn adds a color-coded grouping to your chart? Options are A. Style, B. Hue, C. Palette, and D. Color. Let us know the answers in the comments below. So now, let's get started. Setting up is simple. Open your terminal and run this command. So if it's already installed in your laptop, then it will show you the requirement already satisfied. So to check the version that you're using in Seaborn, you can go with this command. So as you can see, the version is also shown. Let's understand how Seaborn thinks. The syntax is elegant. Once you get the pattern, you'll be able to use almost any function easily. Every Seaborn function follows a consistent pattern. So these are the 3 key parameters you'll use everywhere. That is data, X and Y columns. And hue is a parameter that is used to map the colors to categorical or numerical data. This is the template for almost every Seaborn chart. And SNS is our Seaborn. Plot is the kind of chart you want, like scatterplot, bar plot, or histplot. Data takes your pandas data frame. And X and Y are the column names you want on each axis. Once you understand this pattern, the rest is just remembering which plot type to call. So now let's quickly understand when to use Seaborn and Matplotlib library. Seaborn is when you want statistical plots fast, when you need automatic aggregation like mean with confidence intervals, or when you want the output without configuring every element manually. And use Matplotlib library when you need pixel level control or when you're building very custom chart types. And also when you need to fine-tune a Seaborn plot further. Seaborn ships with several classic datasets that is used for learning. So let's load 3 datasets throughout this tutorial. So now when we run it, the tips dataset captures the restaurant bills, and the Titanic has passenger survival data, and Iris contains flower measurements, and this is classic machine learning dataset. Now let's understand about different plots. Univariate means we are looking at one variable at a time. The goal is to understand its distribution and how the values are spread and where they cluster and whether there are any outliers. And histplot is a modern way to plot the distributions. Now let's quickly go through that. So as you can see here, the smooth kernel density evaluation parameter, and it is great for spotting the shape of your data. So it's basically used for smoother distribution visualization. So here in the output, the KD plot, that is kernel density estimation, it draws only the smooth density curve and no bars at all. So the fill equal to parameter shades the entire area under the curve. It makes it easier to see where the bulk of the data is. So the color parameter sets the fill color. So use KD plot when you want a clean, elegant view of distribution, and that is shaped without histogram bars cluttering the chart. Now let's understand about bivariate plots. So bivariate plots explore the relationship between 2 variables, such as if one thing changes, what happens to the other. So let's talk about this output. Here, each dot on this chart represents one restaurant visit. So its X position shows the total bill amount and the Y position shows the tip, and the hue equal to smoker. The parameter colors dots differently for smokers and non-smokers. It lets us see if smoking correlates with the tipping behavior. And the style equal to time parameter, it changes the dot shape for lunch versus dinner. That's 4 dimensions of information visualized in a single chart. So if you take a look at the upward trend, bigger bills generally receive bigger tips. So as you can see here, the bill is 50 and here he is a smoker. As you can see, the total bill is larger here and the tips received is larger as well. Now let's quickly explore line plot. So in the output, the line plot draws a line connecting the average tip for each party size broken down by the day of the week using hue as day. Seaborn automatically calculates the mean for each group and it adds a shaded confidence interval as well around the line. It shows how certain we are about that average. So it shows us whether larger tables tip more and whether that pattern differs across different days by the week. Now let's quickly understand categorical plots. So in this output, this plots the average total bill for each day of the week and it is split by the gender using hue. So the black vertical lines here on the top of each bar are 95% confidence intervals. So they tell you how reliable the average data is. And a short confidence interval such as Friday, here, it shows us the data points are confident in that average. A tall one means its variability and Seaborn calculates all of this automatically. But in Matplotlib library, you need to compute it manually. So now let's understand about count plot. So this is the output of count plot. So unlike the bar plot which averages a numeric column, count plot simply counts how many rows fall into that category. So here it counts how many Titanic passengers were in each class, first, second and third. And hue equal to survived here, it splits each bar to show survivors versus non-survivors. So in this output, we can see that third class by far had the most passengers, but the lowest survival rate. Now let's go through the box plot. So the output here, a box plot is a chart that shows you the summary of your data in one box shape. So the line in the middle of the box is the median, meaning exactly half the tips were above this value and half were below it. So the bottom and the top edges of this box shows where the middle 50% of all the tips fall. So most of the typical tips live inside this box, and the lines stretching above and below this box are called whiskers, and they extend to the highest and the lowest values in your data. Any dots that are going high and low are the outliers. So people who tipped unusually more high or more low compared to everyone else are known as outliers. And hue equal to smoker splits each day into 2 boxes side by side, one for smokers and the other for non-smokers. So you can compare both groups without needing 2 separate charts. Now let's quickly understand about violin plot. So here a violin plot combines a box plot with a KDE curve. So the wider the violin at any point, the more data values exist in that range. The split equal to true parameter is a powerful trick. Instead of drawing 2 completely separate violins for each hue group, it draws one violin with each half representing one group. So this makes it extremely easy to compare the distribution shapes of the smokers and non-smokers side by side. So as you can see here on Thursday, the smokers are more compared to the non-smokers. So the violin width is larger for smokers compared to non-smokers. This is how violin plot works. So now let's understand about themes and styles. Seaborn has 5 built-in themes that control the overall background appearance. So the syntax for that is, so you're telling the Seaborn to set the style as white grid for the clean background with grid lines. Dark grid can be used with grid lines with dark background. And white is used for minimal white background. And this is used when there is no grid and dark background. Ticks is when you want a white background with tick marks only. So as you can see here, the code is executed. You can call this once at top of your notebook and it applies globally to every chart you draw. So now let's quickly understand about titles, labels, and legends. So when you assign a Seaborn plot to a variable called AX, you get access to the underlying matplot access object. From there, set_title function adds a little title with custom font size and weight. Set_xLabel function and set_yLabel function, it replaces the default row columns names like total bill with clean labels including the units. And the legend function customizes the legend title and position upper left. It keeps it from overlapping the data points clustered in the lower right area. So now let's understand about hue, size, and style. These 3 parameters encode the additional dimensions in one chart. So this is the output. In this single chart, it has 5 variables simultaneously. X and Y gives us the 2 primary axes, and hue is the day that changes the dot color based on the day of the week. such as Thursday gets one color and Friday another, and so on. And size makes the dots physically larger for bigger dining. For example, sixth table gets higher dots compared to second table. And style equal to smoker, it changes the marker shape, such as circles for smokers and cross mark for non-smokers. That's about the scatter plot here. So now let's quickly analyze about multivariate plots. So pairplot, one of the first things any data scientist runs on a new dataset. It plots every numerical variable against every other. So as you can see here, the pairplot automatically creates a pair of scatter plots, one for every combination of numeric columns in the dataset. That is, the iris dataset has 4 numerical features, so pairplots creates a 4x4 grid. That's 16 charts generated from a single function call. So the diagonal calls, it is where a variable would normally be plotted against itself. So the hue equal to species colors at every single point by flower species, making it obvious for which feature combination it best separates the 3 species. And this is called exploratory data analysis. Now let's quickly go through the heat map. So here first the tips.correlation, it calculates the Pearson correlation coefficient between every pair of numeric columns. It produces a table of values between -1. So think of it this way. Imagine asking how similar is my height to my height. So the answer is obviously perfectly identical. So it's comparing a column to itself. So it will obviously be 1. So every single row will match exactly. And this is why the diagonal of every correlation matrix is always 1. So now let's go through the total bill versus tip, that is 0.68. Here the bigger the bill, the bigger the tip is. So when total bill goes up, the tip also tends to go up, and when it goes down, it tends to goes down. Now you might think why it's not 1, because it's not a perfect rule. Some people on big bills tip poorly and some people on small tips are very generous. So the relationship is strong but not perfect. So it's 0.68 and not 1. If we see total bill versus size, it's 0.60. So more people, more orders and bigger bill. That's when 0.60 comes in. So the bigger party size tends to give a bigger bill and smaller party produces a smaller bill. So why it's lower than 0.68? Because party size does not control the bill as directly as you'd think. So 2 people can order steak and wine and spend more than a table of 4 ordering cheaply. So the link exists, but it is a bit looser. Hence it is 0.60. Now let's go through 3 projects. So here the survived column contains 1 for survived and 0 for did not survive. When we use it as a y-axis in bar plot, Seaborn automatically calculates the mean, which equals the survival rate as a proportion. So a bar at 0.75 means 75% of the group is survived. So here the first class passengers, particularly women, had dramatically higher survival rates. So this is the age distribution of survivors versus non-survivors. Here the KD curves on the same chart. That is 1 for survivors and 1 for non-survivors. The common norm equal to false is critical here. It tells Seaborn to normalize each curve independently. So both the curves have equal area, and even though the groups have different sizes. So without this, the smaller group's curve would appear as a tiny bump next to towering curve. So the result clearly shows where the age distributions differed between those who survived and those who did not. Now let's quickly go through the restaurant tip analysis. So here first we create a new column called tip_PCT by dividing the tip by total bill and multiplying it by 100. This converts the tip into a percentage. So this matters because a $5 tip on a $20 bill is generous, but $5 tip on a $50 bill is quite low. So the raw tip amount alone, it doesn't tell the full story. We then plot this percentage by the smoker and non-smoker groups using box plot, which shows us the typical tipping percentage and how consistent it is, and whether any usually high or low tippers exist for each group on each day. So now as we've seen the restaurant tip analysis, let's understand about the business intelligence dashboard. So as you can see in the output, now we can see histogram plot and bar plot, box plot and scatter plot. So here the plot.subplots of 2 into 2 creates a 2 row by 2 column grid of 4 empty chart areas, returning the overall figures as fig and a 2D array of axis slots. So figure size of 14,10 that we've written, it sets the total canvas size in the inches. So the key to placing each chart in the corrected slot is the axis para. That is ax equal to axis of 0 to 0, it goes to top left. That is to the histogram plot. And axis 0,1, it goes to top right, axis 1,0, it goes to bottom left, and 1,1 goes to bottom right. And the subtitle adds a single title across the entire figure. As you can see here in the output, there's the 0,0 axis and 0,1, 1,0 and 1,1. So the title layout function, it adjusts the spacing automatically so panels never overlap. So now we have done with the business intelligence dashboard. Let's quickly understand about Seaborn plus Pandas, GroupBy and Matplotlib integration. So this basically splits the data frame into two groups that is based on every unique combination of day and time values. So the tip.mean function, it calculates the average tip for each of these groups. And the reset_index function, it converts the result back into a flat regular data frame. That is necessary because Seaborn expects standard column-based data frames, not the hierarchical index structures. So this approach is useful when you need custom aggregations, medians, standard deviations, counts, or beyond what C built-in estimation handles on its own. So now let's quickly understand about how while-in-plot works with Seaborn and Matplot library. So in this here, we've written a code in such a way that while-in-plot, it sets the title as tip distribution by day, and the split should be equal to true, and the data as tips, and the X column should be named as day and Y as. So we start by creating a matplot figure and axis object with plot.subplots, then pass this axis into the Seaborn while-in-plot. So it tells Seaborn exactly which canvas the panel should draw on. So after the while-in shows, the ax.axLine function, it draws a horizontal reference line at the overall average tip value. This is pure Matplot library code layered on top of Seaborn chart. So the dashed red line that you see here, it makes it immediately obvious which groups tip above and which fall below average. So this is how Seaborn and Matplot library works together. Now let's quickly save our charts. So here the plot.saveFigure function, it must always be called before the plot.show function because show function clears the figure entirely from the memory. That is DPI equal to 300, sets the resolution to 300 dots per inch, which is the standard for print quality output. So make sure to save it before the show. So the bbox_inches is equal to tight automatically crops the saved image to fit the content snugly. It prevents axis labels and titles from being cut off from the edges. So the SVG saves as a vector file, meaning it scales to any size without pixelation. It's ideal for charts that appear in different sizes across different media. Now let me tell you some visual storytelling tips. First, lead with the insight. Tell your chart with the conclusion and not just the variables. Next, use color purposefully. Every color should communicate meaning and not just the decoration. Next, reduce the chart junk. Remove the grid lines, borders, and legends that doesn't need extra information. Choose the right chart. For distribution, use history plot, and for comparison, use bar plot, and for relationship, always try to use scatter. And annotate the key points. Use plot.annotate to call out the most important insight directly on the chart. So let's quickly understand what are the common errors you will be facing while working with Seaborn. So this could not convert string to float. This happens when a categorical column is being used when Seaborn expects numbers. Next, when you use the old displot function, Python throws a future warning telling you that this function is outdated and it will be completely removed in a future version of Seaborn. So the fix is simple here. Just replace it with histogram plot of KD equal to true, which does the exact same thing. It draws a histogram with a smooth curve on top. It's just the newer supported version of the same chart, so you can use this. Hue column has too many unique values. Hue works best with 2 to 6 categories, so delete them first using pd.cut function. The next is when a plot appears but shows nothing. This is when you call plot.show before adding all the customization. Always customize first, then show last. So the following are the best practices that you can follow while working with Seaborn. Always set a figure size when you show subplots. Use the assume function at the start of your notebook for consistent style. Always label the axis and add titles. Save the high DPI versions, that is dot per index, to 300 for reports and presentations. Alright, now we're going to write one connected block of code that creates a complete professional 6-panel analysis dashboard using everything we've learned. Let's walk through it. So here we start by creating a large blank canvas that is 16 to 12 inches with the master title on top. Then figure.add underscore subplot, it divides it into 2 or 3 column and a grid of 6 panels. So the panel 1 is a scatter plot. It plots the sepal length versus width colored by the species. It shows whether the species separate by sepal shape alone. The next one here is box plot. It compares petal length across the species. Setosa is immediately visible as having dramatically shorter petals. So here, as we can see, the length of the petal setosa is very less compared to the other species. Next we have is Heatmap. Here it shows a correlation between the 4 numerical measurements. The species is drops first because correlation function only works on the numbers. Next here we have KD plot. It gets a KD plot of petal width with 3 overlapping filled curves, 1 per species. It shows the full distribution shape and exactly where the species overlap. Next here we have violin plot. Violin plot gets a violin plot of sepal length across the species. It combines the summary statistics of a box plot with the full distribution shape of a KDE. It shows that the sepal length is weaker separator between species compared to petal measurements. And here in the panel 6, that is count plot, here it counts the samples per all the species. It confirms all the species have exactly 50 rows, perfectly balanced data set. So finally, we have type.layout function. It fixes the panel spacing. The save figure, it saves the dashboard to 300 dpi before memory is cleared. And show function, it shows everything on the screen. So here in the code, we've just written the things that it should be shown here. For example, if we take the heat map, the correlation should be true and the CMap should be cool warm. And we set the title as feature correlations. And the subplot is 2, 3, 3. That is the rows, columns, and where it should be placed. And the species, the iris.drop of species axis equal to 1. So we've used a correlation function here, so only numbers will be considered. It is same for all the plots. We've written a code in such a way that where it should appear and how it should appear as the output. So this is about a final project. Feel free to modify according to your requirements and change the figure size and the subtitles and the colors accordingly and try it with your own requirements. Now you have gone from zero to building a professional multi-panel analytical dashboard with Seaborn. Here's a quick recap of the video. We started with installation and basic syntax, and we walked through the full range of plot types from histograms to violins, and we mastered the customization with themes, palettes, and labels. We built real-world projects on Titanic and restaurant data, and finally built a complete 6-panel dashboard, panel by panel, with clear purpose behind every single chart. If you find this tutorial valuable, hit that like button, subscribe to our channel for weekly tutorials, drop a comment below with what you have built. I'd love to see your dashboards. Until next time, keep learning. See you in the next one.